Okay, we've got here another integral from the MIT Integration Bee 2024, regular season 17. We've got the integral of 2 to the x times x squared dx. Okay, to get started with this, what I want to deal with first is just the fact that we need, in the base here, we want this to be x, or we want it to be e. So we can do this little trick where we rewrite our 2. We can just write this, I can rewrite this as ELN2. And then this whole thing is actually to the x power, so we just kind of bring this in with exponent properties, and I can write this as e ln2 times x. But then we have it in this form. It's actually not too bad to deal with. ln2 is just a constant in front of the x. This is a classic case where we want to use integration by parts on this. So what I want to do is let's just use the DI method or tabular integration over here. I think let's differentiate x squared because it'll reduce all the way to 0. And we can just integrate this because it's going to be easy to integrate. We just have to deal with that constant. So we're going to have e ln2x. Coming over here, we'll have plus, minus, plus, and we'll start to differentiate. So we'll differentiate x squared, and we have 2x. I'll differentiate again, and I get 2. Differentiate one more time, and this becomes 0. Now taking the integral here, ln2, again, that's just a constant. So all we need to do is just write this as e ln2, and then we just need to bring out that constant in the denominator. So we'll have another ln2 there. And this is going to be the same integral over and over again, so we're going to do the same thing again, bring out another copy of ln2, and this becomes ln2 squared, and then for the last time, we get the same thing, and then this is going to become ln2 cubed. So now since we've got a 0 in our last row, we don't have to worry about integrating this last row here. We're just going to take our solution on the diagonals and forget about this here. But one thing I want to keep in mind is this thing we have right here. This, remember, is just the same thing as 2 to the x because of all this stuff. Just going in reverse, this is 2x. So when I write down this solution, we have this thing in common for every term, but I'm going to write it like this. We'll write it as 2 to the x, and we'll bring that out front. And then for the first term, we're going to end up with x squared over ln2. Then we have a minus sign on this one, so it's going to be minus 2x ln2 squared. And then for this last one, we're gonna have a plus 2 on this, and it's gonna be all over ln2 cubed. And we could actually leave this, but let's actually factor out an ln2 all cubed, just to clean it up, just to try to clean it up a little bit. So let me make some space. So what I'll do is we'll have our 2 to the x out front, and then we'll have this all over ln2 all cubed. And then from here, for our first term, this is gonna become ln2 squared times x squared. And then here for this, I can write this as minus 2 ln2. And then for this last one, we're just gonna have a plus 2 here, parentheses, add a plus c, and that's it. Okay, there you have it. Pretty straightforward problem from MIT 2024. Thanks everyone for watching. Have a good day.